should I start now or give it
Yes, so welcome everyone back. You can see the papers in the link that I just sent in the chat. And if you have questions during the talk, you can just write in the chat. Now let's welcome Richard Lee from University of Washington to talk about his paper on KissGlass, greeting gesture recognition using smart glasses.
Cool. So thanks for the introduction. So as Bo mentioned, I'll be talking about KissGlass, greeting gesture recognition using smart glasses. This is done in collaboration with people from friends at KAIST and at Georgia Tech. So, okay, cool. So computing has started moving into ubiquity, moving from pretty static laptops to mobile smartphones, and now they're going into the environment and onto the body. So of course, one of the main things with computing is that we need ways to interact with them. And so in the academic community, we develop novel interaction techniques to explore new ways of doing so. And so these often represent technological feats, right? So new ways to sense different physiological measures, new ways to power the sensing. But one of the problems with these techniques is that they're often they also often have issues with discoverability and naturalness. Luckily, humans have been developing natural gestures for centuries. So they've been developing ways of facilitating human-to-human interactions. And so, for example, there's hugging, there's shaking hands, high-fiving, hand-waving, things like this. And so these are already ingrained into our cultures and our normal way of doing things. One natural gesture that we want to call out is cheek kissing. And so this is a common greeting done in mostly in Europe and some in South America and Africa. So as you can imagine, there are many different ways of performing cheek kissing. So for example, which side you start on, how many times you do it, and things like this. And so interesting enough, we can actually use this information as a way for context sensing. So for example, if I notice that you perform a kiss starting on the right cheek and then do one on each side, I might be able to infer that you're from Spain, for example. And so why would we want to do this? So ways we can use context sensing based on cheek kissing is, for example, if I am walking and listening to music and my music playing device detects that I perform a cheek kiss, then maybe it would pause the music automatically to help me fully engage with the partner. By detecting which country we're in, we could turn on a translation tool for automatically. We could passively build a log of human interactions, which makes, for example, automatic diarying possible, which is very helpful for people, for example, with depression, reminding them that they interact with all these people on a daily basis. So we used off-the-shelf smart glasses for our experimentation. So these are the Jins meme glasses. They have EOG electrodes and they have a 6-DoF IMU. And so we collected a gesture set of different number of repetitions of kissing, as well as starting on different sides. We also performed a nose bump, where apparently in the Middle East, it's common for two people to bump their noses together. And as a check for practicality and segmentation, we also collected some data for walking. And we did this data collection in 2 sessions, in a pilot session and a full session. So this is an example of the data that we're looking at. So this is the accelerometer. You can see how the person is turning towards the right, leaning in, leaning back, turning towards the left, leaning in, and then leaning back to the neutral position. Given this very temporal data, we looked at using a simple algorithm, KNN, K nearest neighbors, with dynamic time warp as the distance metric. And so we conducted 2 experiments. First one with the pilot study. And so here we were looking for tuning hyperparameters as well as selecting sensors. And we found that the accelerometer by itself actually performed the best with 91% accuracy, while K was set to 1. And so using these 2 parameters, we went ahead with the full study performing tenfold cross-validation, we got 83% accuracy, and with leave one user out. So this would be if we train on the whole world and we gave it to you and let you try it on for the first time, we got almost 75% accuracy. So these are some encouraging results to start with. So discussion and future work. Of course, collecting more ecologically valid data would be helpful. That would be a lot better if we were actually in Germany and if we were in a pandemic right now. Better sensing and modeling techniques. So here we were interested in looking at potentially using the EOG if we could extend the sensing to detect other human contact, for example. And modeling techniques, of course, with the rise of deep learning, there's a lot of opportunities there. And then finally, multimodal gestures. So in this talk, we've talked about one specific gesture, the cheek kissing, but perhaps we could combine this, for example, with shaking hands. All right, in conclusion, hopefully we have motivated recognizing natural gestures such as cheek kissing for context sensing and other applications. We've demonstrated the capabilities of using smart glasses for recognizing such gestures. And finally, we have offered future directions for natural gesture recognition. And that is it. I can open up for questions now.
Thank you very much. Greeting gestures using smart glasses.